Hello and welcome to tutorial number 4. In this tutorial we're going to discuss batteries and cells and series and parallel connection of batteries and cells. If we take any two different metals, for example this metal could be copper and this could be zinc, and a liquid that conducts electricity and reacts with these metals to strip electrons off the positive terminal and to place electrons onto the negative terminal. We're producing a displacement of charge using a chemical reaction. One of the earliest batteries, or cells I should say, because a battery is a group of cells. One of the earliest cells was the Leclanche cell, invented by Volta, and it consisted of sal ammoniac, which is the old chemical name for ammonium chloride, and copper and zinc, and that produced a voltage between the positive and negative terminals of around about 1.5 volts. All electric cells work the same way. Nickel-cadmium cell has nickel and cadmium as the electrodes, and potassium hydroxide as an electrolyte. You don't have to remember that. You won't be assessed on the construction of cells. A car battery has lead and spongy lead as the electrodes, and a dilute sulfuric acid as the electrolyte. An electric cell in a car battery produces around about 2 volts. I've also drawn the symbol for a cell on the screen. There it is there. And you need to remember from the symbol that the small terminal is the negative terminal and the longer terminal is the positive terminal. The actual voltage produced by an electric cell depends upon the type of cell that it is. A Leclanche cell produces about 1.5 volts, and a lead acid cell, car battery, produces around about 2 volts. And cells are all different voltages depending on their construction. An interesting thing, if a metallurgist wants to know if two metals are the same, for example if two coins are the same, he can simply attach a couple of leads to each of the coins and dip them in some soft drink or salt water even, and measure the voltage between the two coins. If the voltage is practically zero, then the two coins are made from the same metal. If they're different, there will be a voltage. The more different they are, the greater that voltage will be. Electric cells can be connected in series to increase their voltage. Let's just get a cell. Okay, there's one cell. Now that could be a 2-volt cell. If that was a 2-volt cell and I connected in series with it another 2-volt cell, let's get another cell. I haven't got a line there, I'll put that in a moment. So if we have two cells in series, the total voltage is now double that of one cell. So if these were two 2-volt cells in series, the voltage across the ends would be twice the cell voltage. In other words, if they were 2 volts each, between here and there we would have 4 volts. This would be negative and this would be positive. Two cells make a battery. Let's put another cell in. If we have 3 cells in series, then the total voltage will be 3 times the voltage of one cell. So if they were 2 volts each, we would have a total voltage between here and here of 6 volts. If they were 1.5 volt cells, that would give us a total voltage of 4.5 volts. Most of the batteries we buy today are just batteries. They contain groups of cells, usually connected in series. A 6 volt lantern battery has 4 1.5 volt cells in series. A 9 volt transistor battery has 6 1.5 volt cells in series. A car battery has 6 2 volt cells in series. Cells are connected in series to increase their voltage. 1.5 or 2 volts from a cell is not enough often to say start the starter motor of a car or run an amateur radio, so we series the cells up to produce a battery. The word battery is an English word for a group of things. We not only can have a battery of cells, and we've dropped the of cells and we just call it a battery these days, but we could have a battery of chooks, we could have a battery of cannon. We can also connect cells in parallel. These cells are connected in parallel because all of the positive terminals are connected together. Remember, the positive terminal is the long terminal, and all of the positive terminals are joined together, and all of the negative terminals are joined together. When we do that, we increase the capacity of the cell to deliver current. If one of these cells could deliver 1 ampere for 1 hour, then a single cell is said to have a capacity of 1 ampere hour. If we were to connect 3 cells in parallel, the total capacity of this battery would be 3 times the capacity of one cell. And so if one cell was 1 ampere hour in this battery, then the battery would be 3 ampere hours. So by connecting them in parallel, we increase the amount of current that the cells can deliver over time. The voltage in a parallel connection doesn't change. So whether we've got 1, 2, 3 or 50 cells in parallel, the output voltage is the same as any single cell. So in a series connection, we increase the voltage. In a parallel connection, we do not increase the voltage, we increase the current capacity, the amp hour rating of the cell. Here's an experiment that I often perform when I'm teaching children, but it's a fun thing to do. I've actually used my digital multimeter. If you don't have a digital multimeter, I'd suggest you get a cheap one from somewhere like JCar, because you can pick up a good digital multimeter for about $25 or $30. Cheap one. You can get them for 10, but I'd recommend spending 25 or 30 and getting an auto ranging multimeter. What I've done in this experiment, which I do often, is I've just got 2 lemons and I've driven into the lemon an iron nail, a piece of copper wire, and so what I've created there with the lemon juice and the 2 dissimilar metals is an electrolytic cell, an electric cell. And I've done it again. I've another lemon, copper wire, and an iron nail. And then I've connected the iron nail to the copper wire. So I've made a battery out of 2 cells. And you can see that each cell is giving me around about 0.95 volts. And the 2 cells in series is giving me 1.9 volts. Now I've connected 3 lemon cells in series to produce a lemon battery. And look at the voltage. I'm getting around about 0.95 volts from each cell. So 3 times 0.95 volts. And you can see my output voltage there from the 3 cells is almost 2.9 volts. You could use a lemon battery like this, if you had enough lemons, to produce 9 or 12 volts, and you could power a little transistor radio, or you could power maybe some LEDs. I've had LEDs running on lemon batteries for weeks. So just in summary, when cells are connected in series, the output voltage of the battery increases. When cells are connected in parallel, the current capacity of the battery or cells increases. In the top row, we have 4 1.5 volt cells connected in parallel, and that gives us an output voltage of 1.5 volts. The advantage of doing this, we don't increase the voltage, but 4 1.5 volt cells in parallel will last 4 times longer than one single cell giving you 1.5 volts. So the current capacity is increased by connecting cells in parallel. In the bottom diagram, we're connected the cells in series, positive to negative, positive to negative, positive to negative, and the output voltage is then the sum of the voltages of the cells. So we've got 4 1.5 volt cells. That gives us an output voltage of 6 volts. That's how a lantern battery is made, the 6 volt ever-ready lantern battery. If you break one of those open, you will find 4 individual separate cells in that soldered together to produce a 6 volt battery. To prove that point to you, I've actually got a lantern battery. You can't see all of it. There's the top of the lantern battery, and I've broken it open, and as you can see inside there are 4 individual cells, and they're actually soldered in series. So that would be, this cell here would be soldered to the zinc case, which is negative. So we're going positive, negative, positive, negative, positive, negative, positive. 4 times 1.5, because these are zinc carbon cells. The positive terminal is a carbon rod. The zinc case that the battery is in is the negative terminal, and the electrolyte in there is ammonium chloride. That's called a Leclanche cell. Alkaline cells are not Leclanche cells. They're higher, heavier duty cells, and they contain different materials than the Leclanche cell. The Leclanche cell is the everyday common dry cell. Let's have a look at some of the questions you could get in the standard exam. There are not many questions on cells and batteries in the standard syllabus. A few more in the advanced syllabus. You'll find those questions in samplequestions.doc. You should print them and follow through with me. And the drill software that tests you on this tutorial is drill 1 and 2. It's a combined drill. Okay, first question is, lead acid cells may be connected in series to, well, I think we've worked that out by now. You place cells in series to increase the output voltage. Question 2.2, in this diagram the voltage across the terminals A and B is what? Well, the cells are connected in parallel, and when you connect cells in parallel, you increase the current capacity of the cell, but you do not increase the output voltage, so the voltage will remain at 1.5 volts. So let me scroll down. Question 2.3, 10 1.2 volt cells when connected in series produce a battery with a maximum voltage of, well again, if you're connecting cells in series, the total output voltage is the sum of the voltages of each of the individual cells. In other words, 10 times 1.2 volts is 12 volts. Question 2.4, 6 1.5 volt cells are needed to provide for a 9 volt transistor radio. The cells are connected, well, to get 9 volts from 6 1.5 volt cells, you would have to connect them in series. Six 2-volt cells, when connected in series, produce a battery of 12 volts. It's a car battery. A car battery is around about 2.2 volts when it's not on load. And so a car battery is really a bit more than 12 volts. It's a little bit over 13 volts, but we normally speak of it as being 12 volts. So 6 2-volt cells in series will give you 12 volts. Cells are never or very rarely connected in series and parallel. If they are connected in series and parallel, there's usually some sort of electronic circuit to control the charging and discharging of the cells. That's it for cells and batteries and tutorial 4. Thank you for listening, and do please try the drill software and test yourself, and I'll see you back in your next tute. Cheers for now. This is Ron, VK2DQ.